Hi guys, welcome to Geek Coding Academy. Today we'll see the collection framework chapter 2, that is list interface and its implementation. So guys, in our previous video we talked about on what is mean by collection framework, and we also discussed on core interfaces of this collection framework. So if you have not watched that video, please watch that video prior to this. So I'll give you a brief overview like what our previous topic or previous video we discussed on that. The collection framework is designed like it will be added to Java after Java 2 version. So the collection framework is nothing but we have a predefined classes which can be used to manage our data. It makes a developer life easy, and it will saves a lot of time to a developer. Instead of writing our own data structure from scratch, we can use a ready-made already available data structures to structure our data. So this collection framework starts with two main interfaces. One is collection interface and another one is a map interface. These collection interface have sub interfaces like list interface, set interface, and queue interface. Again, queue interface has one more sub interface called as a DQ interface. Similarly, for a map interface, we have subclasses which extend the map. Which implementing this map, such as we have a some of the hash map, link dash map, and tree map. Similarly, for collections, under collection interface, like we have a list, right? So under list, we have a array list, linked list, vector stack, and so on. Okay. So in this video, we are concentrating on list interface and its implementation. So list interface is a sub interface of collection interface. Okay. So in our previous video, we saw what are the default or generic methods available in collection interface. All those methods will readily available in list interface. Along with that, some of the methods were been added to this list interface. That will be for this list related. Means list interface. What it mean by list interface? We'll see. When we need to use this data structure, that also we can see. Okay, let's start our chapter 6.2. Let's begin. So what do you mean by list interface or what and its implementation? Let me tell you. List interface in Java is a part of Java collection framework. I already told. In collection framework, we have collection interface and map interface. Under this collection interface, the first sub interface is a list interface. Okay. Yeah, that it extends a collection interface. That I saw like under collection interface, list interface will come. And it represent ordered collection of data, collection of elements. Like when we want to use this list interface or classes under this list interface, when we want to store our data in such a way that the insertion order is must be preserved. Like when we are inserting, that order should be preserved. Then we can go with the list interface, means child classes of this list interface, like array list, linked list, vector stack, and so on. Okay, and it will allow duplicates also, but they preserve the insertion order. Okay, the list interface provide some of the methods, generic method, to access, insert, or delete element by their index, making it more versatile compared to other type of collection. Other collection types, it was more versatile. So mostly used concept in collection framework is list only. So below are the key feature, like what is the key feature, methods, or implementation of the system interface in Java? Let's see. First, we'll see what all methods available in list interface. Okay, we have a add method. What do you mean by add is adding an element to the collection. Okay, where its insertion order is definitely preserved because we are using this list. And add all, in add all we'll give an index and collection, some other collection, so that all elements present in that collection will be added to our list under at the specific index. Okay, get, this is used to take the retrieve the element present in a list at a particular index. Okay, set, set is nothing but replace, like we need to replace the element present at the particular index. Okay, so index of, if you pass an object, suppose if pass a element, we call this method of index of and pass an element, it will check in our list for that element and we return the index of that list, index of that element. So last, first occurrence, in this case it's a first occurrence, index of element If you pause, it will check in the list for that element and it will pass the index, but while checking it will check the first occurrence. Suppose duplicates are allowed, we already saw in list, like it will give us the first occurrence of that element. It will forget, it will not look into other occurrences, only the first occurrence will be taken care in index of. The last index of, similarly, we have another method called last index of. It will look into the last occurrence of specified element in the list. If there is no element present, both this method will give -1. Okay. So sublist is nothing but like it will take a two parameters from index to two index. So it will like it just like a returns a portion of list between the specified indexes, like from which index, from index to two index. Okay. And here both like from index is inclusive and to index is exclusive. Suppose like if you want a like sublist of from index 3 to index 7, so it will give us the return, it will return the sublist from index 3 to up to the index 6. It will not include the last index. So that is all we need to keep in mind while calling this method. So these are all the readily available methods in list interface. This is what about we talked about an interface. Let's see what are the classes which is implementing these interfaces, because directly interface we can't create an object, right? We have to create an object through classes, but these interfaces is just to create a proper structure, which will like I already talked about more on this in my Java syntax and Java fundamentals. Like you can go and watch those in my YouTube channel. So let's see what are the classes which is implementing these list interfaces. There are a lot of classes implementing list interfaces. I'll show you in IntelliJ once I open my editor. But here I have noted on some of the main classes which are implementing these list interfaces. Frequently used classes. What all this is? Array list, linked list, vector, stack, which is a child class of vector, and copy and write array list. So let's see one by one what all this. Array list. So this is the syntax for an array list. Array list is a class which is a child class of list interface which implements this list interface. Okay. New of array list. We use new operator to create an object, right? Like new of array list, we create an object of this array list, and this will be um the reference of this will be stored in this reference variable which I created. Here I'm giving same array list name, and which is of type list of, and we need to define like the data which I'm going to store in this collection, string type of data. And that's it. After that, using a reference variable, I'm just invoking a method which is available in this array list. Uh, that array list dot add. We already saw in the list interface. The add means like adding an element to a collection, right? So add of Java, array list dot add of Python. Two elements I have added to this list. Okay. So these are add and all. This array list class will get from its parent interface list. Overview, if you can see, this array list is totally built on dynamic array principle. So it's backed up by dynamic array concept. And most used, it was one of the most commonly used list in implementation. In list, we have other types also, right? Array list, linked list, lot of types, but the most commonly used is array list. So if you ask for any new programmer, even though you don't know the complete concept of a collection framework, still they one point or other they may use this array list. That how famous it is. It is clean, neat, and to store a data and to retrieve data. This array list were mostly used. It's mostly commonly used for list implement. It like the main advantage of using an array list is it is a fast random access. Means like we have a data stored. When we want to fetch a data, when we want to get a data or get a element from that collection data, this array list, if you use this array list, we'll get it in a O of one constant amount of time. It doesn't depend on the size of the collection. Okay. So if my collection of data is very small or collection is big, but if I use that a format of array list, I can able to get any element within a constant amount of time. Okay, and it is very resizable, and null values are allowed. But the main thing is it is not synchronized. It's not a thread safe. Like what is thread safe? What is synchronized? When we go to our thread class, I'm going to teach about that in threads. So use cases when we are using this early, like when frequent access, like accessing is more, in my application, accessing a data is more rather than storing or updating a data, then I can definitely go with an array list. So here frequent access by index is needed, and there are more reads than a write operation. Then I'll go with an array list. The key methods available in array list, we already saw, like add to add a element to array list collection, get to get the element at the particular index, set to set the element at particular index, remove means just delete a element in that collection, size, it will return the size of the collection data. Okay, when you come to about performance after using this array list, like what is mean by the performance? Like performance, when you come to performance, it's fast in terms of access, like O of 1, I already told. What I mean by O of 1, O of n, big O notation, these are all, it will determine the performance of the logic. Okay, when I start about data structure and algorithm, so after this Java, I'm planning to start about data structure and algorithm. There I will explain you detailedly. For time now, you may think of like O of 1 means constant time. Okay, that means like if I have a my array list, suppose you take an array list only, array list of size 100 elements. If you want to get one element, I get one constant amount of time, I can get that element. Suppose if my array list consists of 10 lakh data, I want to fetch one data, it will again take constant amount of time only, because it's not dependent on the size of the my array list. That's what we represent in O of 1. But suppose when you want to insert or delete an element in my array list, so it will take O of n. O of n means it will be depend on the size of an array. Sorry, size of an array list. Suppose like if my array size is of 10, then it takes 10 unit of time. If my array size of 10 lakh, it will take 10 lakh unit of time. So as array grows, my time also increases linearly. That's what it represents O of n. So for any, like if my application requires more insertion or more deletion or more write operations, then there is a big no for this array list. If my application is like there is a frequently I'm getting data at the particular indexes, and there were very less write operation, then this array list is a very good suitable data structure to structure my data. Okay, let's see the next type of class which implementing this list interface is linked list. So this is a syntax where I use new linked list to create an object which is of, like I stored in this reference variable, which is of type list of string, because this is also child class of list interface. The method you can see here also I'm using dot add, because these are all the methods coming from in the parent class, sorry, parent interface. Okay, the add is common for both array list and linked list. I'm just adding up here, but this is implemented as a doubly linked list. Okay, and the feature of linked list is this class is this will implement two interfaces. One is list and another one is a DQ. Okay, when I went into a DQ topic, I'll talk about more on this. What is DQ? But you may think of like DQ is also an interface under this list. Uh, Okay, under it will come under queue interface. Okay, and also this list is a interface. So both interfaces it will implement. So this is where you can see multiple inheritance through interfaces is possible in Java. This is one of the example. Here a linked list which is implementing a two interfaces. Okay. So multiple inheritance concept applying here, but it will only allowed in through interfaces. That's this is one of the example. Okay. DQ is nothing but double-ended queue. We'll see that. So like it will be used for fast insertion and deletion. We already saw in array list, we can't do any write operation, but this linked list is for write operation only. Okay. For for get operations, if use for a linked list, it will take O of n time. For write operation, it will take O of 1 time. So it's completely like opposite of array list. In array list, Get operation is constant amount of time it will take O of 1. For write operation, it take O of n. Here, it was for get operation, it's very slower, but for write operation, it was much faster. Use classes is simple when frequent insertion and deletions are required in my application, especially at the beginning or middle of the list. Then I definitely go with a linked list. So the key methods available in this linked list is add first means adding to first of the collection. Add last means adding an element to the last of the collection. Remove first and remove last similarly, removing an element at the first and remove last it will be removing the element at the last. Get first is the getting element at the first index of the collection, and get last is the getting element at the last index of the collection. Okay. Performance wise, if you talk about accessing time is linear. That means like as a collection grows, as a linked list collection grows, the time will grow. That's a linear. But insertion or deletion, that is write operation, is very fast. It's O of n. O of 1. That's constant amount of time. So it will not grow with the data, the get operation time. Let's see in another class called an vector. So yeah, the same new of vector, I created an object with a reference. I'm returning to this variable, which is of type list of our type of data I'm storing to this collection is string. That's I'm referring here. Sorry, I'm uh, defined here. Okay, this is also a child class of list interface. So add methods, you see, it's similar to how in my array list and linked list. But the main thing of this vector is from vector, it's a synchronized version of an array list. Vector is similar to array list, but array list is not synchronized. It's not synchronized and it's not thread safe, but vector is thread safe and it's synchronized. So it automatically resizes like array list. Oh, array list, suppose like array list have some initial amount of data reserved when we create a array list. After it's filling up the data, it will automatically resize data. Similarly, vector also resize because it's completely type of array list only. It is also backed up by dynamic array concept. Like, however, being synchronized, it is like little bit slower than array list. Okay, let's come to any use cases. Means we need a thread safe operations. We can go with this thread safe concurrent operation. We can go with a vector. It's same like a array list vector, similar to array list, but due to synchronization overhead, like it was little bit slow compared to array list. Okay, let's see a stack, which is the extended version of vector. Stack, I created an object of new of stack. It will create an object and allocate some memory, and that references I'm capturing here in this variable reference variable, which is of type stack of string. Okay, like stack is a child class of vector. I think here some of the methods will be changed because why? Because I'll tell you, this is a very old legacy class. This is very old class and it is a legacy class that extends a vector. Here, instead of add, we need to use a push. Okay, stack means you can think of like stacking of books. Suppose if you want to store a books on a table, what you'll do is you'll keep one book on top of the another book on top of the other book, and while taking back, you take whichever at the top, right? Like it will be like at the top book, which will be added at late, but it will be taken first. Okay, that concept. So adding a data, we'll use a push method. It's a legacy class and it represent leaf order means last in first out. Suppose like I added a books. Okay, the last book which I added first, but it will go to last in leaf order, last in first out. The top book which I'm taking at first will be added at last, right? Like suppose like you may think of like that stacking of books. So you just stacking of books 1 to 10th books. The 10th book you'll pick first when you're taking out. That's the concept. Like but the 10th book is the last book to be added to the list, but it was the first book to be taken. This represent a leaf order, last in first out. So methods, common methods are push. Push means add the data to the stack. Pop means take out the first element of that stack. And peek means no, don't take, just peek out which will be the first element. Okay, just look into the first element uh, are specific to stack. So let's see when what is the use cases? Like use cases is when LIFO behavior is required. Means last in, first out. Key methods is push, means adding a data. Pop means taking out the first element of the in the stack collection. Peek means we'll take out the first element, but will not remove. In pop, we'll take out the first element, we'll remove that entry in the collection. And empty means just check if my stack collection is there any data present here or not. Like it will provide us the boolean return value. Like if there is any data, it will provide us true. Otherwise, it will give us false. Let's see in another class which extends a list interface is copy and write a list. I created an object new copy and write a list, which will provide me in a reference variable. I'll capture up this variable, reference variable here, and which is of type list of string, I know. And similarly, like for our array list and linked list, this add method is used to add the data to it. It's a thread safe portion of array list. How vector is, this is also similar. And it's create a new copy for underlying for every write operation. Like write operation, it will create for write operation. In order to make it little bit faster, we can go with this class. So what it will do is like for every write operation, it will create one more copy of an array, and it will somehow make write operation little bit faster compared to a list. But memory, it will take some lot of memory because every time when we do a write operation, it will create a new set of copy, right? So it will take some memory. Use cases is when there is a more read operation. Similarly, like this is similar to an array list. When there is a more read operation, we have to use it. But write operation, it's not that uh, preferable. And the thread safety is there. So excellent for reading often, but slower for writing of n only. Because each mutation creates a new copy, new array copy. Okay. Let's see the comparison between implementation. Okay. Array list, it is backed by dynamic array, but it's not thread safe. Access time, often constant time, but write operation is often. Linked list, it will back by doubly linked list. So it was implementing both the list and queue or DQ, and it's not a thread safe. This is also not thread safe. Access time of n, access in the write operation of 1. From vector onwards, these are all mimic the array list only. Like vector, they're all backed up by dynamic array concept only. All these three, vector stack, copy and writer list, these are all thread safe. But access time, they're all often constant amount of time. But write operation, they're all linear amount of time it will take. But it will depend on array size. What is summary? Let's see a summary. Like array list, it's prefer of a scenario where random access, like accessing is more important than in a modification. Linked list is a good choice when a frequent insertion and deletions are required, especially in the middle and the beginning of the collection. Vector stack are legacy classes, but it's used in thread safe scenarios. This copy on write array list is suited for concurrent scenarios with a frequent read and not frequent writes. Okay, concurrent scenario, like it anyway, like when you are trying to write, it will create a copy, right? Like for concurrent operation, it will seek more deep on what is concurrent, what is threads, what is thread safe, what is synchronized. I think we'll discuss in our future video. This is just only concentrating on collection and how to use these classes. Okay, so these are all about theory. Let's see the practical code. So let's see. So just a minute, guys. I'm just plug my computer to charger. Okay, yeah. So I'll open my IntelliJ. Okay. So list interface, right? When you go inside of this list interface, this is the list interface. In IntelliJ, this is the list interface, which will be extending this sequence collection interface. If you go inside of it, again, it will extend this collection interface. I told collection interface is the root. Below of it, list interface will comes in picture. So let's see what are the classes this list interfaces has. In IntelliJ, if you're using an IntelliJ IDE, just click on this Control H. So it will list all the hierarchy where and all we are using and which are all interfaces. It's like child interfaces and child classes both. So you can see here. So both interface and classes are under this list. So I picked only five in like notable classes. Okay, I picked like linked list, array list, and also vector. Okay, under this vector we have stack. I told you that, and also like one more copy other entire list. This one we picked. There are other also like identity array list, and also under this linked list we have some classes, keep alive, stream cleaner. These are all like it's all depend on requirements, but whatever I choose these, the most commonly used and most notable classes, subclasses of this list. So let's see. Like I have written one class here called live collection demo because we're talking about collection, sorry, list collection, sorry, list collection demo. Like we are talking about the list from collection framework. I have written a class here and I have written a main method which is of type public static void main. The control flow enters here. I created one array list, new of array list, which is of type array list, and it is of type list of string because string type of data I'm going to store here. Using an add operator, sorry, add method, I'm just creating a Java, Python, and C++. I'm adding to it to this array list. I'm just printing the array list here. After that, I'm use this set method. Set method is to replace the element, right? So I'm giving an index one to replace okay replace with a JavaScript. So I'll show you. Let's run this program and I'll show you. Okay. See here. Initially, I written Java, Python, and C++. I print the array list value here. Java, Python, and C++. After that, for index one, I replaced with the JavaScript. Like zeroth index is Java, first index is Python, and second is index is C++. The first index Python is replaced with JavaScript. Okay. Similarly, let's see first everything. So after that, I'm printing up here, and after that, I'm printing. I need an index two. What element should be there? So arraylist dot get method we use, and we need to pass the index number like two, 0, 1, 2. C++. I get a result here. Similarly, I created one more example for a linked list example. I created an object new of linked list, which will create a reference variable sorry reference, and I'm catching that reference with this reference variable English, which is of also a type of list of string because these are all subclasses which are implementing the list interface. So using an add operator, sorry, add method, I'm just created this. I'm just adding this data: apple, mango, banana, and also I again use add of index one with orange. So what happened here is apple, mango, apple, banana, mango will be there, right? Like orange will be common first of the before apple, it will be added up. So after that, linked list after insertion, like what is the like I just added one more element here because in linked list write operation is faster. We already saw in the PPT. So I'm just removed this mango. This element got removed. So after removed, what will be the result I'm printing up here? So vector example, I created a vector which is of a list of string. I'm just adding all these values. I'm remove the index one. This is similar to an array list, the vector. I remove this index one means BMW are removed. So after removal, what will be the result? For stack is a child class of vector. Stack of string is equal to your stack. In stack, I just use this push to add a element irrespective like before with the others and all it will be like add for stack because it's a legacy classes. So stack push means I'm just adding an HTML. HTML will be go or sit at the bottom. Again, I push CSS. CSS will be placed on top of HTML, and JavaScript will be placed on top of CSS. Okay, I'm printing up the one. Top element I need to pick. Stack tag pick like it will pick the HTML. Again, popped element. Stack tag pop means HTML element will be picked up and it will also simultaneously it will removed from the stack. Okay, after that I print the stack up here. So copy and write array list example. This is one of the child classes which is implementing a list interface. I created an object here where reference will be captured for this in this reference variable which is of type list of string. I'm adding all these thread 1, thread 2, and thread 3. After that, I removed this thread 2. Thread 2 got removed and I'm printing up here. This is similar to an array list only. So totally, I'm printing out the values of this copy and write arrays. So let's run the program and see output of all the examples. So this example we already saw. For the linked list, apple, banana, mango will be there. After that, apple, banana, mango. Yeah. After that, I added orange at the first index. Yeah, first index. Okay, apple is at 0th index. First index is banana. So banana will be shift to next second index, and first index orange will come and sit here. Okay. So after that, I removed the mango. The last one mango I removed. So after that, apple, orange, and banana will be there. Okay. So vector. For vector, Tesla, BMW, Audi. I removed the BMW, Tesla, and Audi will be there. Okay. HTML, CSS, and JavaScript. First, I placed HTML on top of CSS, on top of that JavaScript. When you see the first element, it will be like JavaScript. When I pop the element, first element, JavaScript will be popped out. Means it will taken the first element, and also it will removed from the list, from the stack. So when I print the stack, it will be HTML and CSS only. So copy on write array list is similar to array list only. Thread 1, thread 2, thread 3. Three elements will be added here. I removed thread 2, then thread 1 and thread 3 will only available. Okay. So when I print those values, iterating over those values, thread 1 and thread 3 will be there. So guys, these are all about list interface, which comes under collection interface. And collection interface is one root of collection framework. So these are all about list. In our next class, our next video, we'll talk about on set interface and what are the subclasses or child classes which implementing this set interface. We'll see. Okay. So in set, like what is the hash set, linked hash set, tree set, like what are the different methods available for them. So we'll see in detail. I hope in this video you understand completely the list interface and the subclasses which implementing this list interface like array list, linked list, vector, stack, etc. This is some of the notable classes we discussed in this video. I hope you enjoy the video. I hope you at least gain some knowledge from this video. So please subscribe to my channel. If you like this video, share this video to your friends and colleagues, and please turn on notification bell. Please hit the bell icon to turn on notification. So when I upload a new video, you'll get an instant notification to your mobile. So I'll meet you guys in my next video, that is set interface and its implementations. So till then, keep watching, keep learning. Thank you. Bye.